Hello there, it's Lana Tucky, and I'm going to show you in this video how to use your calculator to both determine a point estimate for a population mean as well as construct a confidence interval for a population mean. All right, so we have here the FBI compiles data on robbery and property crimes and publishes the information below. A simple random sample of pickpocket offenses yields the losses in dollars shown below. So somebody had $447 stolen, somebody had $313, and so on. So we want to obtain a point estimate for the average dollar loss. Well, since you want a point estimate for the average, what you're really looking at is mu. Of course, mu is for all pickpocket offenses, which we don't have the time to go grab every single pickpocket offense, nor are all of them reported. So what we're going to do is we're going to use our sample here to construct a point estimate, a single best guess for what that mu would be. And of course, we learned back in chapter 3 that your best guess for mu is x bar. So we need to be able to find x bar for these data, which let's go to stat, edit, and we're going to enter that data in. So let me make this smaller. There it is. All right, so 447, 207, and so on. At least I think it was 447. Yes, it was. Okay, 447, 207, and so on. All right, so I'm going to pause here. I'm going to go type in all these numbers. All right, they're all typed in. Let me see if you can see them. There they are. Okay, so there's the data right in there. So now I want to come up with a point estimate. So there's a couple ways you can do this. The first way we learned back in chapter 3 is to just run one variable statistics on L1, leave your frequency list blank, calculate. Oops, oh, it was there. There it is, 513.32. So there you go. That's your x bar. Now there's another way you're going to see to do it in a little bit, but let me show you that in a second. So x bar, oh, I can't see it, so small. Stop that. Sorry, my computer is driving me crazy. There we go. Equals 513.37, I think it was. Oh, 32. There we go. That's our point estimate. That's our single best guess for mu. And that's what a point estimate is. Point because it's single, estimate because it's a guess. All right, wonderful. Now there is another way to do it, and I I'll wait on it and I'll show it to you in a minute. So let me run through here and how to create a confidence interval, which is after all this t-distribution stuff, some of which we've already done. There were the instructions right there. So we're going to come up with a confidence interval for those data that we just put into the calculator. So we're going to show the formula, which is x bar. Nope, not that one. X bar. There it is. Plus or minus. And then t alpha over 2 s over the square root of n. That's the formula. Okay, so x bar we just found. It was 513.32 plus or minus t. Well, we'll figure the t part out in a second. So I'll put that right there. T, and then s. S we can get out of the calculator as well. S is sx, the standard deviation. So it's 262.23. So 262.23. Square root of n. N was, I'll have to scroll down to get to it. Oop, no, there it was. It was 25 right there, 25. So 25. T. T is the rough one. Let's go figure T out for a second. All right, so remember, we have a 95, what do we have? 95%. Okay, so we have a 95% confidence level. That means that alpha is 0.05, right? Because they're complements of each other. That means that alpha over 2 is 0.025. Our degrees of freedom is n minus 1, which is, I don't remember, 25 minus 1, 25 minus 1. 25 minus 1, which is 24. Okay, so there's your degrees of freedom. That's the row you're going to go to in the table. And there is your alpha over 2. So that's your column. So if you're going to use the table, you would do that. So let me grab the table. So you go to 0.025, go to the 24 row, and you get 2.064 right there. Right? So T alpha over 2 is 2.064. Now you can also get it with the calculator. Let me show you how. You would do inverse T, and then T, the T distribution requires the area in the right, or the area in the left tail, which is 0.975. See, the table uses the area in the right tail, so you use 0.025 because 0.025 is a little bitty part in the right tail over here. But to use inverse T, you use the left tail, which is this light gray part, which is the 95 in the middle plus the other 0.025 over on the other side. So that makes 0.975. So I would use 0.975. Let me grab the calculator and do it. So it's inverse T, 0.975. Our degrees of freedom was 24. Paste. Enter. 2.064, just like the table came up with. So, and again, you could use the calculator if you have it. If you don't want to, you can use the table. I generally pick ones that the calculator does because that way you guys can grab them. Oops, I'm sorry. At least mean that the table does. There we go. That is not what I want. There it is. Jeez Louise, I can't find it. All right, so it would be 24. So 0.975 comma 24, and that's our result right there. All right, so let me double underline that so we can see it right there. Okay, so going back to our formula, so this is kind of a note over here, right? We need to figure that out kind of on the side, what our T is. All right, so now we go back here and we put 2.064 right here. All right, now our result is such a mess to do it this way. So if we could just run the calculator and have the calculator do the run for us, do the work for us, that would be great. So we go to Stat, go to the right to Tests, and you're looking for number 8, which is T interval, right? Because you're making a T interval here, right? You're making an interval and using T values. So grab number 8. Now here you have to make a choice. And this is a very important choice, data or stats. Now data is the one you use if you actually physically typed in data into a column, which I did. I put my data in L1. So I just pressed second 1 because I didn't have L1 in there. And then my confidence level I want to be 0.95. Go down to calculate, press enter, and it'll run it for you. And here is that other way to come up with a point estimate. So you actually don't have to do one variable stats. You can actually just run T interval off the data. And when you do that, it'll tell you the parts of the formula you need. It'll tell you that it's 513.32 for X bar, and it tells you S is 262.2. The only part it doesn't tell you is actually the hardest part, which is the T value over here that we had to find by ourselves. Okay, so we get results of, and I don't remember what they were, 405.08, 405.08, comma, 621.56, 621.56. And there you go. That's your confidence interval. And of course, you could type it in by hand. It's not like anybody's stopping you. And you might have to if you don't have a more powerful calculator. But that's how to get the calculator to do it for you. All right, so we now know how to find t-value again and how to find a confidence interval right here. And we learned 2 ways to find the point estimate. You can find it running one variable stats, or you can find it when you actually just do the interval itself. It'll tell you what the point estimate was. It's X bar, which is 513.32. All right, we're all done with this section. I'll see you back here for more.